Good morning. So I welcome you all for this fall semester 2021-2022. Like you all are very eager to get along with the new semester. I too was waiting to meet you all. I was so keen to look at how many students are going to register for this course and so on. And I am very much aware, as you all, that this course is an elective course that falls under program elective category. Also, this would act as an university elective course for other specialization of engineering students. Because this course is basically a multidisciplinary course. It is not only that you are going to learn this course, it's all about only dynamics. It is all about understanding dynamics for product development. So the course Vehicle Dynamics that you have registered is a key course in automobile manufacturing industry. And the knowledge of this course is really going to add strength to a automobile engineer, whether is going to be, you are all going to be working as design engineer, or you're going to pursue higher studies to know further the technology that go in driving automobile industry, or you're going to work in research center of any institution, or in any industry, OEMs or suppliers. You see, this course learned is going to give you more value added to you, because this course is going to integrate your other branches like control system, your signal processing, your coding. So these all are very important to understand your vehicle as an important entity and subject context. So that is why this is very interesting course. I think you would also have a lot of expectation, might have gone through the syllabus content, and you would have discussed with your seniors. I think there are students from this SAE club. So that is the reason. I could see there are complete 65 students have filled this elective course. And this course expectation is very much. See, it is not an easy course. The same course is also offered in our university. I offer to MTech students as well. So this is again for MTech students, it's become a core course. It's compulsory. They have to learn this course in their MTech curriculum. And as an undergraduate students, you have chosen this course to learn as an elective. It is not something that if you have in mind, okay, you register, you could have listened to your seniors that this course is easy to pass, everyone get good grade. That's all fine. But they have got it all because they have really put in more effort. That's the reason why your seniors in last fall 2020-2021 has got good result, right? So I have seen the students' enrollment very carefully, one by one. You are not today put on your video, but I have gone through your photographs. I was very keen to know who are my students, how do they look like, and what are their year they belong to. Because since it's an elective, it's not one particular year that students are able to register. So I could see the registration from first student from energy, mechanical and energy engineering specialization. And then I could see registration from mechanical engineering with automotive specialization. And I could see many of mechanical engineering students have registered this course, right? And in the year 2018 students batch and 2019 students joined batch, up to 2020 students joined batch. So you have senior students, you have intermediate and also juniors. All are a mix of good blend of this. So I am very much concerned that I know that this course has got a prerequisite that you are good at your engineering mechanics. So you know what are the system of forces, what are the effects on bodies, and what bodies would undergo different motions. These all are very fundamental that you are aware. So you would have studied statics and dynamics, And if you are good at that, this course is going to be very joyful, right? If you are not, you have to parallelly refresh your basics. And all the students registered have finished that course, engineering mechanics. So I don't think you will have any difficulty. But this course, if you look at on first hand, you see you also require to understand the specific part of your dynamics, which you have not studied, especially I think 2020 admission batch students. There are many, around 35 students in the class out of 65. So those many students, I think you would not have gone through more of learning a course or fundamentals of vibration. Of course, everyone in the class know what is simple harmonic motion from your school days, and you would have got prepared many competitive examinations, so you know what are the importance of vibration, and that is called the mechanical vibration. So if you have to also understand that in requirement basis according to the course, because this the vehicle dynamics falls mainly into a category called one of the parts. So you are going to study this vehicle dynamics in different modules. That is to facilitate us to organize our learning in a respective manner. So you would be able to see, and today we will just go through, as this class is an introductory class, to get a big picture of our course. That's my objective of today's lecture. We will go through the syllabus content, what are the objectives of the course, what is that every student would be able to gain the skill, that is what we call it as course outcome for this course, and then what kind of content and the textbook that would be useful for you to go through parallelly after listening to my lecture. And so on. So this is all we will just see, and also of course we will understand what are our assessment configuration today. So this is what a formal kickstart of any course of our university we follow. So I do follow the same. So today's class we are going to have it in the same things what I discussed, to have a big picture of the course, right? I actually, if we are all physically there in the class and we have an interaction, I always get interact with you all and ask you questions, and you would speak all. We could of course do that because of the time constraint. I would presume that you are all awakened and so keen that you are listening to me now. I go ahead, and we will due course of time we will get introduced, because I have uttered everyone's name myself and entered one by one while creating these teams. So I am familiar with most of the students. There are senior students registered here, are my students, those who learned mechanics and strength of material course under my teaching. Of course, 2020 batch students are new to me. Let us get to know each other as we progress in the semester. Nothing to worry. I would individually know every one of you. Right. So, and also let us adhere. I know your senior students, if you ask, those are present in our class, they would say that always, no, we're running short of time. The lecture hour completing in hour is very difficult. Of course, this course, as we go more detail into our modules, you see that the time management of learning as well as teaching is very important. So I would try to adhere myself with the time limit recommended 45 minutes. In case I have to go a bit more than 45 minutes to take till entire 1 hour of time, and you have to rush for the next period. Absolutely no, there's no issue of asking me, because once you are logging into the lecture, your attendance would be downloaded, and your time stamp, what time you come and what time you go, would be there. If you are leaving 5 minutes just before, and you are leaving while I was teaching, that's absolutely no issue. And that part you can again view in the video lecture. I would try to adhere to the timeline, right? That's what is the exercise that I do before taking any class, that to deliver the content in 40 to 45 minutes, so that it would facilitate you to get ready, relax to get into next lecture hour, right? Okay. Now, what we will do is I'll share my Active Inspire board, and we will go through the introduction of our course to get the content of the course, right? So before that, let me just to give you, this is always a good practice that you make your learning, right, through appropriate notes preparation. So during my lecture, if you are making good notes, that is what is your assignment, right? Your assessment part, if you look at, you have your assignment. 10 marks is the class notes preparation and interaction during class, your attendance, how you are learning this course is what will be assessed. So at the end of the course, I expect that everyone have got your own material prepared after this, listening to lecture, reading textbooks, in a systematic way, right? That is your digital assignment. So the last day of instruction is the deadline for submitting that. And then we would have two quizzes, and you would have, we will see that quiz dates, deadlines, we'll have to adhere to that. I would not change the quiz date. So if you have any other work, please plan without distracting to your quiz dates. So we'll have 20 marks for quizzes, two quizzes, and digital assignment 10 marks. Of course, you know our regular procedure of CAT 1, CAT 2, which would fetch you 15 marks, and final assessment exam 40 marks. So this is that our assessment configuration. Of course, I will share the table to you, and this time there is no additional learning marks for this course. So whatever that you want to do, you please put all your effort in exercising, learning this course, and exhibit your learning. So that is sufficient. There is absolutely no need of thinking of additionally what to do all. So additionally you are doing is it's always better. We will have the discussion that will help you to maybe choose a topic from vehicle dynamics for your capstone project during your final year, right? So let me just share my screen and we'll go ahead with the lecturing. Am I audible to all of you? Is it clear that what I say?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, fine. What I will do first, quickly we'll go through with the content. So I'll just share this important files, and I hope every one of you would have gone through this circular for academic calendar and related processes, right? So I just have highlighted our important things. So today we start our semester, and we have your CAT 1 examination from 12th September till 19th September. And your CAT 2 examination is from 24th October till 30th October. And final instructional day is on 10th December. And final exam starts from 13th December. So your CAT 1 of our course is on 12th September, 24th October, and 13th December. If there are no changes in the academic calendar, that may be announced by Dean Academic Office, right? So this is very clear for us. And then the course syllabus, if you look at, this is the syllabus now going to get revised for the new curriculum of the batch who is going to get admitted now. But this is that the syllabus, maybe yours batch is the last batch to go through this. The content wise, whatever the revision is made is not much changed. Maybe it is organized in some logical flow, right? So there are 7 modules, and one module is what we call it as contemporary issues, maybe some advancement in the course and related practice in the industry. So for that, so this syllabus copy and the calendar and the assessment scheme, I would post in our Teams channel, and you would download and have it in your reference. And this is what is your assessment configuration scheme, which I would do after this lecture in our VTOP. So the course has got this 4 important objective as it was prepared during the curriculum preparation, syllabus preparation for this particular course. So what is the main objective is that the fundamentals of vibration and its application in vehicles. So vibration word is very important and catchy word. That's what is going to take 1/3 of your vehicle dynamics portion. That's what is called vertical dynamics. We will understand that in detail. So that's one of the objective. And the other second objective is to understand the behavior of tires. So if you do not have tires on your vehicle, the vehicle is incomplete, right? The motion of your vehicle is all because of tires. That's what is that pride of tires that you say. Of course, you have power plant. When the power plant, your engine transmission system can be put on, but that motion to realize what you require is wheels to rotate and roll on the roads. So you see that you have the behaviors of tire to understand in our course is also another important objective. And when you have your vehicle motion, the motion should be safe enough. So when that motion won't be safe is when it goes out of its equilibrium of steady motion. So that's what we call it as stability of vehicle. So we would have an objective to understand vehicle stability study, right? And importantly, a specific and stability called roll stability, and how do you handle your vehicle. So this is all no in importantly cover the objective of your course, and the expected outcomes are 5 outcomes. And we will have these modules are divided according to the expected outcome that students would be capable of doing it. So if we are good at understanding vibrational fundamentals of vibration, you would definitely able to look at physical system can be represented as single or multi-degree freedom system, can be represented by vibration system elements called mass, spring and damper, and you would be able to find out the natural frequency of the system and their modal behavior of the system. So it's basically if we are understanding physical phenomena of simple harmonic motion, and that is all through boundary value analysis problem or initial value analysis problems mathematically to say. So you would be good at evaluating any system, physical system, natural frequencies, whether you represent it for conveniently single degree or multi-degree freedom system. You would be able to find the natural frequencies. And you would be able to predict ride comfort of vehicle. So what do you mean by ride comfort? That's what I was telling, vertical dynamics part of our vehicle dynamics course. And this ride comfort of different operating condition we would be able to predict at the end of this course learned. And another third outcome is understanding performance, how good your vehicle you would be able to say, because you would understand and apply tire behaviors, predict tire behaviors during braking, acceleration and cornering. So this is what is another outcome. So this covers the other part of your vehicle dynamics, where we call it as longitudinal dynamics and lateral dynamics part. So longitudinal dynamics and lateral dynamics part means you have to ride your vehicle on a straight highways, or you have to take your vehicle comfortably on curvatures on the highways, the curved roads on the highways, all. So you are able to integrate the performance of the vehicle, capability of the vehicle to have a safe maneuvering of your vehicle. So that's what would be evident if you understand and you are able to predict the behavior of tires during these are the 3 operating state of your vehicle. Like you brake your vehicle, accelerate your vehicle, or do maneuver or corner your vehicle, you will be able to predict the behavior of tires. So that's another CO course outcome 3. And then as stability is an important objective of vehicle that you are going to learn, you would see what is its role stability of vehicle. You will discuss on it, and the suspension role on stability. You would also study about rollover stability So what are the safety aspects that go into your vehicle to have equilibrium, prevent unstable state because of vehicle roll, right? So you see vehicle severe accidents on highways, the vehicle would be off the highway and on the roadside and off-road, you would see the vehicle upside down and so on. So all because of vehicle gone unstable during drive. So what makes the vehicle to have such a unpleasant, unwanted state is all would be clear to you. And what are the design aspects that go into your vehicle to prevent such unstable scenarios in the vehicle? All you would be comfortably able to discuss. So that's what is that course outcome number 4. And outcome 5, you would be able to analyze the directional stability of the vehicle during cornering. So it's very specific that you would be able to see how comfortably you would able to drive your vehicle with steady state. If at all it goes out of steady state, so you call something called in-plane stability. Yaw plane stability is called. So this word yaw plane, in plane, all you will understand once you understand and reference access system that we put it for a vehicle. Today's class that I will explain you that as we proceed further, right? So fifth course outcome is to look at vehicle lateral dynamics. Handling means it's lateral dynamics. So analyze the vehicle directional stability and during this cornering is what is your fifth course outcome. And these are an important timeline which I was telling you. We will have quiz 1 on 22nd September, quiz 2 on 24th November. So this would fall just after CAT 1 and CAT 2 respectively. You may have 20 marks weightage, maybe MCQ type or descriptive. Let's decide at that time. And this answering and your performance, your marks would help me to make an assessment of course outcome. So of course, this course outcome to get, you have to give your examination. We get it. That doesn't mean that the course listening you are not learned this. So that's why we also have some feedback session at the end, where how comfortable you are learned the course objectives and through your outcomes that you would give a feedback, and that also would be considered to finally make a course delivery assessment. That's all part of our system. That is why we are going to have good accreditations and so on. So anything that we do as an engineer, we should do have some systematic way of doing it and organizing, retaining it. So it's very good system that we follow, and we are also having this NAC visit in this month. End 25, 26, and 27th of August. So see, this is the kind of practice that our university we are following for teaching you all. And you have your digital assignment, as I said, your class notes and course understanding is what all put together 10 marks for you. We have an assessment deadline till 3rd, of course, 13th. Yeah, 3rd December is the last instructional day. So I just have put, so me and your interaction and your class notes preparation, maybe then and there I may ask you to submit it. So based on that, I would make an assessment. So if I complete a module 1, or if I feel that I have taught you that you are good at getting one first outcome, then you would be able, I would ask you to submit your class notes. So like that, I would periodically ask you to submit. So that would help me that ensure that you are all following me while teaching. And that would give you this 10 marks. I just have put the due date is 3rd December. That does not mean you have to, last minute you have to work on it and submit. So that is going to be a regular assessment, digital assignment thing. And then you have these dates as per the academic calendar released. CAT 1 on September 12th. This is CAT 2. I just have to correct this is CAT 2. Please do correct that. This is CAT 2. I will update that corrected one. Right, and then you're fat on this day. So this is your course assessment configuration. So let me just share my Active Inspire board for today's class again. So top, share another. So hope you are able to see this screen. This is lecture number 1. Our course title MEE 2050 Vehicle Dynamics, and this fall semester 2021-22, and this is our course class number, and it was offered in A1 slot. You know, A1 slot Monday morning 8 o'clock, Wednesday 9 o'clock, and Friday 10 o'clock we are going to meet. Of course, we have one virtual class hour on Wednesday 11 o'clock. That would be for you to prepare your class notes or solve some problems or tutorials that I would post for that all, right? So weekly 3 hours of attendance is compulsory, so don't miss any of the lectures. So this is the classical diagram of driver, vehicle, ground system understanding. So this is what is bringing the big picture of our course. What are we going to learn? So look at our course. Here is what we are looking at, our vehicle and its dynamics. So dynamics means it's motion of any vehicle is what vehicle dynamics. So why the vehicle do have a motion is all because of the input that go into the vehicle. So how the input that is being given to the vehicle is all coming from driver. So the driver do give a necessary action so that the vehicle can have its motion, right? So you see here the input through accelerometers to start and make your vehicle velocity, or can be required to brake. So the acceleration or brake is from driver. Of course, when you use both of this, the steering system is what is having a control of your vehicle, right? So the steering system is what is necessary, that vehicle can be driven straight or vehicle can be required to turn all. So the driver in hand has got these controls, and these controls through which is giving the necessary input to the vehicle. And this is not a simple open loop system. So this is called a closed loop system. If you look at the arrow that flows from block to block, they are connected here. So look at the driver, cannot just to give it like that. You all, I think most of you would know driving and you would safely drive your vehicle. You drive because it is all with the visual and other inputs that are on the road. So you drive safely, you don't hit anybody or you don't get your vehicle hit by any others. It's all because of you have a clear understanding of environment. So you have a visual aid and other inputs like the indicators in your vehicle. They are called a safety system in your vehicle. So you start your vehicle, you see have an indication you have not yet put your seat belt. So those are also the input that comes to the driver. So visual and other inputs like a vehicle system, intelligent system. So the driver is very much alerted and he is driving the vehicle by giving such an input. At the same time, driver also could feel another important thing. Whatever the input he gives, he knows that what is he expected. Is the vehicle does it or not would be understood. That is why you have this feedback here. So this feedback from vehicle that goes again to the driver. So driver looks at the environment, like driver inside vehicle feel comfort and he drives, and the vehicle he understands the feedback that comes to the driver as well. Today's vehicle, if you look at, it has gone into a very advanced intelligent system. You see complete automation is possible. So the driver, we say the driver can feel how the automation level in a vehicle that has gone in. So you can just sit and relax once the path is clearly dictated or understood by the vehicle. The complete action of input, which is manually to be given by driver onto the vehicle, or to have, of course, a steering control, all can be automated on today's advanced autonomous vehicle development. But they are not realized completely. They are in developed countries and there are many experimentation, there are continuous development. So How this all are going is because this flow chart. So this understanding of driver and vehicle and environment. So this go into developing such kind of intelligent vehicle, right? So that's what you understand from this picture. And you see there is also surface irregularities. Other than driver, you get vehicle getting input from surface irregularities, because that's an important aspect of interaction of vehicle with the road surface and vehicle with an environment. So aerodynamic input. So you drive in highways at high speeds, you have the kind of resistance to the vehicle called an aerodynamic resistance. At low speeds, you don't feel that much, but in high speeds that are quite substantial resistance on the vehicle, and the vehicle would get that also as an input other than the driver input. And the ground conditions. So the ground condition here and surface irregularities, you should understand. Surface irregularities can be referred to the texture of your road, how the road surface profile is that. So profile and texture are the two terms to go into your road definition. And ground condition is that road is dry road, or is the road ground is off the road, is it an asphalt road or concrete road, is it wet or wet road or greasy road, all when you say that's what is ground condition. So your road surface can be of this type of conditions. So the vehicle which is being driven by driver, of course, getting influenced and has to adjust because of this input from the driver carefully with the ground condition and an aerodynamic input and so on. So if this system does like that functioning from driver, vehicle, road integration, you would be able to get the requirement of your vehicle for which it is designed, for which you buy and you drive, right? That is what we call it as performance, handling, and ride. So this performance, when you say it is all how good the vehicle can pick up its speed. When you start your vehicle, how fast you could gain your speed as you drive on your vehicle. You are seeing suddenly there is a requirement of stopping your vehicle because of there are some road intruders into the highways, that cow crossing the highway. Then suddenly you have to brake, or you go uphill the road and see suddenly it comes down. You do not know ahead of road, and you just to see suddenly something there. At that time you have to go for emergency braking. So how good your vehicle in braking, quickly is it able to stop without any problem, maintaining its equilibrium from its motion to stop, all are referring to performance. You would have seen while initially you learned your driving, you go on a ramp in parking mall parking stations. So you have to go up the hill. So your vehicle has to be good enough to take your vehicle up the hill. So if slope is more and you go up and suddenly the vehicle is coming back on its own, though you give your input, then the performance of the vehicle is not good. So it has to go with that speed that you drive, right? You go on a road, sudden slope is there. You have to come to the lower gear. We say that is all because you require more torques to be given and the time to climb up. So in case I drive in third gear where it is of moderate speed, I don't want to reduce my speed. Still, I want to go up the hill, up the slope. If my vehicle does it, it is good performing, I would say. So that's what we call it as gradability of your vehicle. So this acceleration, braking, gradability, all in one straight line motion. You study 1D motion on highway, rectilinear motion. That's what is called performance. That's called longitudinal dynamics, part of your vehicle dynamics. So you may have to study of an engine characteristics. You have to study about transmission characteristics. You have to look at how brake system work. What are the control strategies that go into brake system called anti-lock brake system. There are traction control system. So such kind of things to be studied in performance aspect in our course we will learn. And then second one outcome of this vehicle is what is handling performance, handling study. So handling means it is curvilinear motion. It is curvilinear motion, right? So you go straight and you have to take a turn. Maybe you will go with the low speed or a low speed car, and you have to park your vehicle comfortably on parking station. So you have to maneuver your vehicle. You're playing with your steering. It's very low speed. Your vehicle should listen to you. And you go high speed highway, and suddenly you have to take a turn during your high speeds. You should be able to do that comfortably without any unstable problem, stability issues. So your vehicle should be driven at high speeds with a steady state, and your vehicle would feel some tendencies at that time called understeer or oversteer or neutral steer tendency, something. So there's something called understeer gradient, importantly to be understood when you have to talk on vehicle handling. So vehicle handling, first we will study for its steady motion, and then we will study for its stability aspects in plane, out of plane. Then we will also study in our course how the suspension system is going to be helpful in fulfilling performance of your vehicle and so on. So that is all we are going to study in handling aspects, and that is what is called lateral dynamics. So when I say vehicle performance, it refers to longitudinal dynamics. When I say vehicle handling, it refers to lateral dynamics. And then you see ride. So ride is what comfort. So how comfort we are while traveling in a vehicle. How comfort driver. So driver has to drive his vehicle for say continuously 8 hours. No problem. Maybe he has to stop in between for natural call. Otherwise, he can be comfortably drive without any fatigue is what is the vehicle ride aspects that we say. So the vehicle ride aspects are looked at by vibrational model. We will have a study in our course, quarter car model, pitch and bounce model, half car model, or a vehicle can be made as a vibratory model in order to understand that the inputs that come into vehicle other than driver, that's from road condition or surface irregularities or power plant engine, your engine and transmission system. There are many sources for make your vehicle to feel vibration and feel noise inside, or create noise outside, or create vibration outside. So the vehicle is going to be a source of vibration and noise itself. It is going to be interacting with the sources like road surface and your aerodynamics, other ground condition and so on. So anything that is interacting with the vehicle can act as a source of vibration as well as noise. So if your vehicle is designed well for to account these aspects of vibration noise with the recommended standards that are there, like SAE Janeva's standard for ride comfort, ISO 2631 whole body vibration of ride comfort. There are many standards like that for interior noise perceived is concerned. So such standards are met by the vehicle, and the driver would pleasantly without any fatigue can drive your vehicle, and that's what we are going to study in ride dynamics part. So what is that we may look at more? How do we model the road? How do you model your tire? So how do you make your vehicle vibration model in order to find out the acceleration levels called RMS acceleration levels, and those acceleration levels are prescribed by limited values for duration of vibration exposure. So if I drive for just from my home to office, it may take some 20 minutes at the max. Or if I drive from Vellore to Chennai, it may take say some 3 hours of drive if I go steadily. So like that, your duration of drive determined by the destination that you reach. So according to the duration of your drive and your exposure time of vibration and noise in the vehicle is also decided. So for that, you see the level of noise or vibration perceived by the occupant are dictated by standards, these values. So if your vehicle falls below those values, that's designed good for ride. So how do you model the vehicle on your hand that is there for assessment of ride, and what are the points that are to be accounted to improve the ride? You make an assessment, you see this vehicle driven at this particular speed is very noisy. This vehicle driven at this particular speed, I feel more vibration. at my at my feet and the floor. Like that, if you make a comment, there are jury tests called subjective evaluation. So before any vehicle launched, the test would be carried out, and the juries would say this vehicle is good, this vehicle is not good, all. So they don't only comment on ride, they would comment on all this performance, handling, ride, and so on. And the comments is because of feel of an expertise driver or juries, and as a test engineer or researcher, that you have to account, yes, their statements are valid, and I would find why do they say that objectively. That's where you see the key of this learning of vehicle dynamics play a role, right? So this all this one slide is bringing in the big picture of our course, and we are going to study our course to look at vehicle longitudinal dynamics to understand its performance, vehicle lateral dynamics to understand the handling aspects, vehicle vertical dynamics to understand how comfort the vehicle. That's called ride comfort part of your course. Of course, these all are realized all because of what an important element that I said, tires, tire wheel assembly. So we would definitely study more of tires and tire dynamics and how the necessary forces and moments are generated at tire road interaction and so on. So these are all in crisp. What is the content of the course that we are going to learn? Of course, I was showing you what is the documented as syllabus, content, textbooks, and so on. And this particular lecture you have listened to me brings in the big picture, I suppose you understand. So we will quickly browse through another 10 slides. I'm not going to much explain you, but we will finish it in another 5 minutes, and that would give us a good start of the course. So if we have understood this is a big picture, we are going to look at longitudinal dynamics performance, where you see this is an important free body diagram. We'll get back to that again. This diagram shows all the external forces that are acting on the vehicle during its motion up the hill, right? We're not going that in detail. We will get back to this diagram again in later. And you see lateral dynamics, handling aspects. You look at your vehicle in this way. It's called bicycle model. You have your front two wheels collapsed and made as one single wheel, and rear two wheels are collapsed and made as one single wheel. And you see that is connected by your frame, and that's why two wheels. It's called bicycle model. Wonderful model, so that you would completely capture handling aspects, whether it is for directional control or stability. You would be able to mathematically understand the physical phenomena. That's wonderful part of our course called lateral dynamics. And then you'll have vertical dynamics, what I was telling you, where you can represent your vehicle as lumped mass spring damper system. So you would see that the picture here, three. One shows 7-degree freedom of ride model of a passenger car. One is called quarter car model. Another one is called pitch and bounce model. So these models can be applied with the Newton's second law and Euler equation. You would be able to derive the fundamental governing equation. Once you have that fundamental governing equation, they are differential equation, ordinary differential equation. There would be forcing function that comes from the road, and then you would be able to find its natural frequencies, its amplitude ratios called deflection shapes, and so on. All because you would have in first hand to kickstart the course learning of fundamentals of mechanical vibration. That's placed in the first module I'm going to teach you, and then we'll get into vehicle dynamics aspect. So this part is what is called vertical dynamics. And you see that surface discontinuity is important thing. This is another important thing other than driver interact by default with the road, with the vehicle. So these are all discontinuities can cause many disturbances, act as a source for noise and vibration. So we will see them in detail. How can we this physical picture, how can we take it as a mathematical form so that we would employ into the mathematical equation and solve for the response of the vehicle. Of course, tire dynamics we are going to study. Fundamental function of tire is not only to support the weight of the vehicle, also to act as a cushion. So vehicle or surface irregularity. So you see it is taking care of ride aspect to provide sufficient traction for driving and braking. So it takes care of performance aspect that we discussed. provide adequate steering control and directional stability control aspect. So if tire dynamics is not understood, tires are not there in the vehicle, we don't call it as a vehicle. And if you do not understand tire dynamics, you cannot call it you as a vehicle dynamics engineer. So tire dynamics is very important. We are going to study them and how they fulfill these three part of our dynamics. We'll understand. And there are tire models. This is a popular model called the Magic Formula yearly model. So we will discuss on this tire model in our course. And this is what is tire axis system. So you have your axis system. You see x-axis in forward direction positive, y-axis in this direction. So your coordinate system, right-hand coordinate system, we are going to look at like that. Instead of looking at like this in engineering mechanics, we have had like that. Now it is like this is SI coordinate system. So your index finger would say the forward direction, x direction. Middle finger is the lateral direction. Thumb shows the ground thing. So with respect to this, we are able to define three force components and three moment components, and important angular definition called slip angle and camber angle and so on. So we'll see them in detail. And this is another picture where from another textbook taken to refer those same things. And it is the vehicle axis system. So we looked at tire axis system in the previous slide. Now vehicle axis system. This axis system essentially to understand what is the response of the vehicle for the forces and moments that are represented in tire axis system. So you see there can be forward velocity, lateral velocity, and vertical velocity. So forward velocity is what make your vehicle to move from one point to the other. Lateral velocity is what is maintaining your vehicle on a course of turn. And vertical velocity is what is responsible for what is the vibration of the vehicle. Apart from that, there are angular measures like you see your vehicle can roll along x-axis like this, and your vehicle can do pitch like the front and off, and then your vehicle can take yaw velocity. So these are 6 degrees freedom, you can say, or these are the 6 responses or the effects that are present because of tire axis system forces. And then a vehicle fixed coordinate system from other textbook. And earth fixed coordinate system. This is very important because you have to have your reference on the ground, Newtonian frame of reference. So from there, you have to look at your vehicle, and we have this additional definition from earth fixed coordinate system. We'll see that also in our course in detail. And your course is catered by this 8 modules we would look at in the syllabus copy. And the objectives and outcomes we discussed at the beginning, and they are again listed here. And the assessment configuration is what is there finally added in this slide, what we also have understood and accepted, right? So with that note, I would stop in today's lecture, and we will meet again on this Wednesday to get started with module 1. If you have any doubts at this point of time, you can ask. Otherwise, I will stop the lecture. Any doubts? Hope we will meet again on this Wednesday. I'll stop recording now.